I'm CK. Today we've got another kit from Gikfun. It's another solder practice kit, this time in a handy little plastic box. We'll put it together, see if we can learn anything from it, see if it's a great solder practice kit, and I hope you enjoy the video. Picked this up from Amazon, as I get many of my general purpose kits from. And again, this comes in a nice little plastic box this time, which means I can reuse the box later, and little plastic boxes are very handy. Service at gikfun.com, gikfun.com URL. I think it just opens up like this. Yep, here we go. Thank you. Give you a Gikfun kit, you can make magic happen. Choice of global million Arduino fans. Well, that's nice for them. Let's see what we got. We've got a battery box, which we won't be using. We'll plug it into a regular power supply. But it looks like they gave us a USB cable, so we can do just that. Good. I mean, I will solder it on so you can see how it all goes on, but I'm just not going to be using it. Bunch of LEDs. Let me dump these out. We'll take a look at them, because there's some capacitors in here. Oh, everything is in here. I'm sorry, they scattered everything in here. There's a chip in here, a CD4017, which is a counter divider. So that's going to be this. So the other chip is probably a 555. I would bet you $1, and it is a 555p. So this 555 chip timer, for lack of a better term, is going to be sending periodic pulses out. This chip is going to be counting those pulses and lighting LEDs appropriately as it gets to them. And we've got a number of transistors. If I could pick them up right. Let's see if they're all the same. 9013s. 9013. Because if they're not, I have to pay attention. If they are all the same, I can just slap them in. These are for the to gate, based on what's coming out of the counter chip. This will gate which LED sets come on, I believe. I haven't looked at the schematic yet, just basing it on what I've seen before. Yep, they're all 9013s. And we've got a couple of electrolytic caps, little guys, 10 microfarad. Ooh, there's a big guy, unless this is a choke. No, it's a big one. Oh, that cap is probably to set the rate on the capacitor rate on the 555, and then this variable resistor will work with it and set the actual output rate of the 555 chip. Unless they're doing it with this 104, even though that 104 is probably a decoupling cap for the counter divider. There are two 104s, so maybe two decoupling caps. And we've got some resistors, probably for current limiting for the LEDs. And one random guy here. And we've got a surface mount style circuit board, but it is not surface mount. This is all through hole. LEDs will go there. Chip, resistors, transistors all over the place. Capacitor here. Variable resistor goes here. Here is the power that we would put the battery box connected to, and this will be the the plug-in connector, so we can use this cable that they included. So that's nice. Board looks good. So that's all nice. And then here we have our piece of paper. Am I zoomed in too far to see this well? Let's see, yeah, I'm going to zoom back out just a little bit, folks. I can't see my viewfinder very well. Okay, so step by step, install resistors, install the LEDs, and all that. Component list tells you how to, the polarity on the LEDs and the electrolytic caps. And then we have the schematic. And yeah, as we can see here, where's my pointy thing? The variable resistor is right here, going into the 555 with this cap, and then we've got the output coming out here, going over into the clock for the counter chip, the 4017, and that hits all the resistors that are current limiting. Actually, those are not current limiting, those are just 1K resistors for fun, I guess. And these all go to Q, these all go to the gates on the transistors to turn, oh I see, it's not turning on individual ones, it's turning on rows. Even though they're not going to be rows, they're interspersed, as you can see here, but electrically on the circuit traces itself, they're in a row. So the output from the 4017 is going to sequentially turn on the gates here in some pattern. I don't know if it turns them all on or if it steps through them. We'll see when we get to it, but that's what's coming out here. That's why Q1, Q2, Q3, Q4 are outputting from there to these gates. And that's pretty much it. So we will get the soldering iron heated up and start putting this fine fella together. We're going to start, as we typically do, with the resistors. We've got 11 1K resistors, 9 200 ohm resistors, and 1 10K resistor. Now, the instructions are a little: install res 200 ohm 1K 10K resistors, install on R1 R21 pad. That's not really very explanatory. So you'll want to go over to the component list, and the component list more clearly lets you know. So if we look at the 1K resistors, it's going to go in R1 and then R11 through R20. So we'll start with that. Start with R1, and we always are interested in how a circuit board takes solder and how close we have to bend the leads to the body. It looks like we can leave a couple of millimeters on each side of the resistor. And here's R1 right here. And we'll put the resistor in. And yeah, we can probably leave 2 millimeters on each side of the resistor body. These are widely spaced holes. So let me get my soldering iron and solder one. Oh, soldering. The circuit board takes solder very well. And you can see it wicked through the through-hole plating, which is good. So that is how the resistors go on. And now we're going to do R11 through R20, then the 10K, and then the 200 ohm, and then the 10K. And there's not much more to say about the resistors. So what I'm going to do is turn the audio down and speed up the playback, and probably cut out some of the installation here, because it's time for you to enjoy resistor time. That's the end of resistor time for this kit, and the resistors all went on very well. This board takes solder really nicely. Now we're going to do one line of LEDs to set the standard down, and then duplicate it all the way along. And the board doesn't have plus or minus on here, but there's a square pad for each LED and a round pad. And if you look by the square pad, you'll also notice that it's got a little flattening. It's not real distinct. This is very clearly curved. This has got a little flat. So the convention for LEDs, because the LED has a flat side on it too, is the short pin, the cathode, flat side goes in the square hole. So we'll lay out the first one, alternating yellow and red. And I'll speed through putting these all on. And we'll talk about it a little more, what we're going to do to secure these well. Now we want these to be as flat as we can, so we could just set them down like that and hope. But what I'm going to do, what I typically do, is I solder one leg of each LED, and I'll just go through all of them right now. And if we take a look, they're not really flat, they're kind of all over the place. So what I do is I will then go back, and with my index finger I'll push on the LED and reheat that one pin I soldered. Let it cool, and that will get us to get all of them. See, you may have seen the legs moved a little bit as I push on it and heat the solder, and it goes flat. Then I take the soldering iron away and I wait for the solder to cool, because I've often been a little impatient, and I let it click into place and then let go of the LED, and the solder is still a little warm and it slips back where it was, which is really irritating. So this is getting them all flat to the board. And now that they're all flat and in line with each other, except for this one, needs a little bit more help. Now I'll go back and do the other lead. That's the first row, and we've got 1, 2, 3, 4, 5, 6 more rows. 1, 2, 3, 4, 5, 6, 7, 8. 7 more rows. Counting is hard to do, and I'm not going to record doing the same thing 7 more times. So I'll turn the cameras off and we'll be back after I've got all these LEDs in place. We are back, and that's all 80 LEDs soldered on. Again, this is why this is a solder practice kit. Got lots of good soldering practice and getting all those LEDs on. And one thing you'll note is there were extra LEDs. That's often the case in these kits, though usually they give about extras of both colors. In this case, they only gave us extras of reds. But what you'll want to do, if you're just starting out, or even if you're not, obviously, is tuck those away. Get a box or a bag or a drawer where you can collect all kinds of spare parts that kits give you, and then you have spares for later on when you're working on something and you drop something on the floor, or it didn't come with, or something like that, and you can go ahead and have a replacement and not slow yourself down. Great way to start your spare parts locker, which if you keep going on this, you'll want to have a whole bunch of spare parts. Now we're going to put the variable resistor, the caps, and the DC power socket on. So first we'll do the variable resistor, and we won't have this LED jump on things. And it's got 3 legs, so it fits in very easily. You don't have to worry about how it goes. That's going to set the rate at which the 555 timer fires off its little signal. And let's see, what else we want to do? We want to do the all the caps. Do all the caps. So let's see where our electrolytics go. This is the 10 micro, and cap 10 micro goes in EC. What? No, you can't just say E. Oh, it's C2. I'm sorry. I got grumpy prior to being grumpy. And these have the actual plus sign where you put the long lead in, so you don't have to worry about the square. And now we've got C3, which, since it's the only other electrolytic, is going to be this 220 micro. And now we'll do the two 104s, the 100 nanos, and they're, as I said, they're decoupling caps. They kind of condition the power going to the ICs generally, so you generally look for them near where the ICs are. And are there more than one of these? Oh, there's only one, but they gave us a spare. Okay, having a spare 104 is never an issue. And then we want to put the power connector on, which will go right here. It's got 3 legs. It's got 2 little holes for index pins. And now we'll solder all these fellas up. I'm going to do this power connection first, resting it on my pinky finger on the back of the board, or the front of the board, whichever way you want to think about it. Get 1 pin soldered. Now it'll stay flat. And just looking around, we can do everything else. I'm not going to trim those leads right yet. I'll get to it in a second. And now we're going to put all of these, what the instructions call triodes, but in the US we typically use triode for tubes and call these transistors. And you'll want to spread the middle leg back and then put it in with the flat side of the transistor facing the flat side of the outline printed on the circuit board. I was going to say silk screened, but I don't think we do silk screen anymore. And they're all on. Now one thing, as you're learning with this, you may notice that each quadrant has a fairly standardized layout because they're doing the same thing. Now next we're going to put the ICs on, and in this kit they chose not to give us sockets. We're just going to solder them directly. And you want to make sure this little cutout notch on the IC matches the cutout on the printed on the circuit board. And sometimes the pins don't want to quite cooperate, so we'll nudge them in there. Again, it makes sense to not use sockets on this kit because you're never going to replace these ICs if these ICs ever fail, which is unlikely to begin with in any reasonable time period. I'm bending the legs in a little bit against the side of my workbench. So no sense in adding the extra expense of having a socket on board. Now that one, yeah, okay, they're both gripping tightly. So I can do all these pins. I'll do one corner each just to make sure they don't shake loose. ICs are all on. Now we'll do one more thing just for completeness' sake. We'll put the battery box on. We're not gonna, as I said, in this case we're not gonna use it, but may as well do it for completeness. So we'll feed the lead through the top, from the bottom up. Bend it around. The one labeled VCC will go in, is where the red lead will go. If I can get it in there. And I'm going to solder that before I do the other wire, just because if I don't, based on my past behavior, I'll knock it loose and frustrate myself and maybe say a bad word on YouTube, but I never do that, so that's probably not going to happen. This is a family-friendly channel. Now we can snug those wires down, and the battery box could go behind it. You could tape it on the back, you could put it like over yonder or whatever. We're not going to do any of that, of course, because right now we're going to power up and get this thing going. Let me turn this light off so we have a little bit of darkness, even though modern cameras are so good that it compensates for missing the light very quickly. I'm trying to see if I've got a spare one already set up. No, I do not. So it's demo time, and I'm going to flip this around this way because my power is kind of out of reach, and it should come on when I plug in. And it didn't. I'm not sure why. Double checking all my solder. Next thing I'm going to do is check my power connector for power. Got my meter set on DC voltage, and it's showing 5 volts. So what's going on here, little fellas? Why are you not coming on? Check for power on the pins. It's acting like this connector is not working. So let me get some batteries after all. I've got some rechargeables. Let's make sure I'm getting power there. Yep. So I'm looking to see what could be wrong. I mean, we should be getting 5 volts right here at IC1. I'm getting half a volt. Why am I only getting half a volt there? And I'm getting smoke. Ouch! Ouch! Okay, so you might have seen me just do that. There were my battery wire started smoking because I couldn't see it, but right here, these two pins were bridged against each other, so it was shorting out. That's why things weren't happening. So when things start not working, look for things like shorts. So there we go. Now it works. And that's how fast it goes. Got a little interesting hitch there. Oh, there must be something else shorted on those. But let me change the speed. That makes it go slower, makes it go faster. Again, setting the rate on the 555 timer, which You can look it up. Look up a 555 timer and learn how you can set the speed on it. It's a very important little chip. Now I'm looking to see why that mid stretch may be not working, and again looking for, it's either going to be a short or it could actually be a bad transistor, because I'm not seeing any more shorts. But I honestly, I'm not going to check all the transistors out, but what I am going to do is I'm going to look at the CD4017 pinout, CD4017 pinout, to make sure I'm going to get this right. Come on, when I tap on stuff, God darn it. Okay, so what I'm going to do here is I'm going to go to ground with one of my leads, and let me double check this. Okay, so ground is pin 8, which will be right here, and I'm going to see if I'm getting, yeah, okay, so I'm getting pulses on, let's start with 1. Oh, I'm going the wrong side. I'm sorry, I was going the wrong side. There's a pulse coming off that one. Pulse coming off that one. Pulse coming off. Oh, I should probably let you see what I'm doing. So on my meter, I'm on ground on the input power to the 4017. Then here's output 5. And as you can see, the meter fluxes every now and again as it goes through it. Same there. Same there. Same there. Same there. Same there. And same there. So the chips are working right. Something that's controlling that row of LEDs. Let's take a look at it just so you can see what I'm talking about. So that will be the 1, 2, 3, 4. 1, 2, 3, 4. So that would be Q5. So let's look at Q5. Even though it's listed as T5, which is kind of interesting. Looks good to me. Let me do what I was doing again. I'm going to probe the go from ground to the gate on T5. There. You can see it pulsing, right? You may not be able to. Let me move it in. Pulse, 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 pulse. Just look for that little line at the bottom of. So the transistor is getting a signal. And as you can see, it's sending 5 volts through every now and again, but something along that row is not working. I'm looking at all the LED solder connections, and they all look good, so I'm not real sure why that row is failing, but doesn't much matter. We get the basic point. And we had lots of good soldering practice. Again, as you notice, I had a problem with shorting here, so you have to be very, very careful on these very close together pins. But other than that, I cleaned it up with my little solder sucker, and it works okay. So we'll call it good. A good soldering kit, lots of varieties of things to solder, and I hope you enjoyed the video.